In this example, we're going to find the least squares approximation to the solution of the system of equations. This is our system of equations here. So the first thing that we're going to do is we're going to put this into a vector and matrix form. So the coefficients in front of our x's are going to become the first column in this matrix, and the coefficients in front of our y's become the second column. And we hit that matrix by xy, so that gives us this side of the equations. And now this is the other side of the equations. This can also be written as our matrix A by our vector x is equal to vector B. Now the equation for the least squares solution for x is A transform A by vector x is equal to A transform by vector B. So let's solve over here A transform A. Now to get A transform, what we do is we take the first column of our regular A matrix, and that becomes the first row of our transformed matrix. Then the next column in our regular matrix becomes the next row in our transformed matrix. Then we hit that by our regular A matrix. And now it's just a matter of matrix multiplication. So just for a reminder, matrix multiplication is basically a bunch of dot products. So our first dot product would be the first column by the first row. So that's 2 times 2 is 4, plus 1 times 1 is 1, plus 1 times 1 is 1 again. Then we take the dot product of our first row by our second column. So that's 2 minus 1 plus 1. Then we move on to our next column, take the dot product of our second column with our first row. So that's 2 minus 1 plus 1. And then the dot product of our second column by our second row. Alright, now let's solve our A transform B. So again, we have our transformed A matrix, and then we hit that by our vector B. So again, this involves two dot products, a dot product of this vector by this row, and the dot product of this vector by the second row. So that gives us 6 plus 1 plus 2, and 3 minus 1 plus 2, which gives us 9, 4. So now let's put these two pieces of information back into this equation here. So we have A transform A by vector x is equal to A transform vector B. And now this is our vector x. And now to solve this, we're going to move this matrix over to the other side by taking the inverse of that matrix. So take the inverse, we have 1 over the determinant of the matrix, which is 6 times 3, so that's 18, minus 2 times 2, which is 4. Then we swap the entries along this diagonal, and we make the entries along this diagonal negative. Now this is just matrix multiplication again. So if you do the matrix multiplication, you end up with 19 and 6. So then our solution is x is approximately equal to 19 over 14, and y is approximately equal to 6 over 14. And this is our least squares solution.